Dear authors and invited guests, welcome to the technical session 6E. Myself Anjali, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the International Conference on Information and Communication Technology ICICT 2023, London, UK. The 8th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th, 21st February 2023, and the virtual event will be held through Zoom today and tomorrow, that is 22nd and 23rd February 2023. I hope you'll enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations, and each presentation will be given 12 minutes for the presentation and 3 minutes for question and answers. And 10 minutes, I'll be raising a gentle reminder for you to conclude your meeting. There is another request to all the participants that please stay connected with us till the closing remarks. And if you have any query or any update, you can write it to me in the chat box. Also, just before we begin, I would like to introduce our session chairs for this session. Introducing our very first session chair, we have Ramesh Chandra of Computer Science, Christ Deep to University, Bangalore, India. He completed his postdoctoral fellowship from the Cyber Physical Systems Laboratory, Department of ICT and Natural Sciences, Norway University of Science and Technology, Helsinki, Norway, and one more postdoctoral fellowship on the International Collaborative Project of a Prediction Model for Pandemic Disease using Machine Learning at Oakland University, USA, and Imam University, Saudi Arabia. His research interests include sustainable technologies, cyber physical systems, path planning, and collision avoidance in artificial intelligence and intelligent algorithms for autonomous systems. We welcome you, sir. Thank you so much for being here with us. Also,
thank you, Anjali. Thank you so much for nice introductions. And welcome on the,
sir.
Yeah, welcome on the behalf of again ICICT 2023. So first of all, as per our sessions, I will call the first presenter, that is the Vidyam Siloshar. So please share your screen and start your presentation.
Hello, everybody. I am Vadim Siloshar.
Sorry for the interruption.
Yeah.
Actually, we have another. Actually, one have another session chair, Professor Meenakshi Sumit Arya.
Could you give me possibility?
So, Anjali, please introduce.
I would like to welcome her as well, sir. If you'll give me a second, we have another session chair, Dr. Meenakshi Arya. Dr. Arya is a research scientist with the real-time analytics of transportation data laboratory at Nova State University's Institute for Transportation. She's an experienced academician skilled in machine learning, big data analytics, algorithms, data structures, and programming languages. Her research interests include data science and analytics, machine learning, deep learning, and digital image processing. Dr. Arya has multiple journals, conference publications, book chapters, patents, and copyrights to her credit. She's a senior Institute of Electrical and Electronics Engineers member, fellow of the Institute of Electronics and Telecommunication Engineers, and a lifetime member of the International Society for Technology in Education. We welcome you, ma'am. Thank you so much for being here with us.
Thanks.
Now we would like to proceed to the presentations. I would like to ask our first presenter, Vidyam Siloshar, to please present their presentation on the title, A Two-Tape Design of Metamaterial Based on a Quasi-Fractal Approach. Dear presenter, you may present your presentation now.
Thank you, Mr. Chairman. Thank you, everybody. I'm Vadim Slusar. I'm ready to start. Because I have problem with electricity now, could you start my video records from page of my report? Is possible?
You can send it to us. You can send it to us. We'll share your presentation. You can then present your presentation.
Anjali, you can set up the next presenter so that while he's setting up and sending you the
Sure, ma'am.
slide deck, you can start with other.
We'll move on to our next presenter. I would like to request our second presenter, Akif Kelmia, to please present their paper on the title Addictive Detection of Gadgets Using Artificial Intelligence. Dear presenter, please present your paper.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good night in Indonesia and London. Apa ini? Masih siang ya. Okay, I would like presentation my paper from my research about addictive detective gadget using artificial intelligence. I would like introduce myself. I am Akif Hilmia and co-author from Muhammadiyah University of Yogyakarta, and the co-author Kiri Wiono from State University of Yogyakarta, Indonesia. Nggak bisa jalan ya? Oh.
Ada tanda panah di ujung itu, Bu. Coba. Yang depannya, yang depan. Yang ke kiri. Itu coba.
Yes.
Itu.
Ya, udah. Outline my paper, breakthrough 3. One introduction, research methodology, and conclusion. In introduction, one of the latest technology then can be applied to the world of education in artificial intelligence technology are often referred to as artificial intelligence. The presence of artificial intelligence technology will cause a lot of unemployment because the role of janitors is decreasing. The expansion of artificial intelligence technology implementation in Indonesia is still rarely encountered. The complex problem in the world of education in Indonesia are one of the reasons why this technology is difficult to adopt in our country. The problem of this study, how was the effectiveness of the application technology with the PKSSD application to addictive gadget in elementary school student. The purpose the study, the khusus discovering the addictive influence of gadget on the emotional social intelligence elementary school student, making the technology easier for student, teacher, parents, and related person to clear our early detection of gadget addictive, improve children character education. Research methodology. This type of research is survey with a quantitative approach to correlational models. The sample of this study was 150 students from 4 elementary schools in Bantul, Yogyakarta, Indonesia. Data collection techniques through questionnaire using the PKS SD application. Data analysis using descriptive statistics and linear regression. Result, this study addictive level of elementary school student gadget. Addictive gadget of elementary school student can be assessed through 3 indicators, namely dependent on something and done repeatedly, having an effect on the psychological, and 3, having an effect on the physical. Yeah. The result of the overall individual. Yeah. The addictive influence of gadget on student emotional and social intelligence. We know with the table regression test output with ANOVA, we know there are significant, yeah, dependent about emotional, social, and addictive gadget. Yeah. Yes, and the result, the addictive influence of gadget on student emotional social intelligence with the linear regression, this output summary, we know, enggak kelihatan, ya. We know R square 19.7%, ya, 97%. Yeah, the result of the study effect on the physical, the addictive level of student gadget belongs to high category on the aspect of having an effect on the physical. Effect on the emotional and social intelligence, the emotional and social intelligence of student is high in the psychomotor aspect and the lows in the cognitive aspect. This is indicates a lack of understanding of the student reason for doing good deeds. Ini anunya gimana nutupin ya? There is an addictive influence gadget on the confidence 19.7%, the mind 80.3% influenced by other factors. Conclusion of the study, artificial intelligence is able to detect addictive gadget of elementary school students. And the conclusion, the addictive level of gadget of elementary school student has high categories. The highest indicators has an effect on the physical, while the indicator has and the physiological categories and the lowest indicator depend on some done repeatedly. The level of emotional and social intelligence of primary school student is category in psychomotor aspect, followed by affective aspect and the low cognitive aspect. In all indicator, is social intelligence include respect for other, responsibility, cooperative, yeah, cooperation, tolerance, affective, communicative with other. This show that elementary school, yeah, when doing good to the other are only a habituation. Even if empathy exists, understanding the reason why they do, so they do not know this. Yes. The addictive effect to social emotional intelligence is 90.7%, and the other, while 80.3% is other factors such as peers, parenting, religiosity, and others. Okay, I think enough, and thanks for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Yes, Akif, actually, I am a little bit wondering how to use the artificial intelligence in your research. Am I audible?
What's repeat?
How to use the artificial intelligence, actually. I'm wondering about that. Can you little bit explain what fundamentally your use of the AI so that you can say that your research is totally based on the artificial intelligence?
Bagaimana cara Ibu menggunakan tuh?
We the application of access with PKIS apa itu access for emotional and social intelligence, we base Android gitu. So we kita bagi with 3 aspect: cognitive, affective, and psychomotor gitu. So the addictive gadget, with the with Android gitu. With Android we access them.
Okay, yes, over to Dr. Meenakshi.
Yeah, even I actually had the same question, that you are just using a normal linear regression model and calculating an R-square. So that doesn't effectively qualify as an artificially intelligent technique. Like I couldn't see anything machine learning or you processing huge data sets or using some kind of technique to it's not even a predictive analytics. You're just driving an inference out of the data that you have. So I think probably you need to rework on your project to see how you can actually call it an artificially intelligent project. As of now, I do not see too much of AI in the project because it has got nothing which is learning from data. You do not have an input stream of data. You are not using data effectively for some kind of a training or even some kind of an inference. So probably you can, look into the whole thing and increase your data set, and then probably do a comparison of various machine learning models available, and then draw some kind of an inference. That can be step 1, which fundamentally every survey kind of a research should have. So here it's like very, very elementary. It's 1 line of code. That's what you've shown us in past 12 minutes. So wishing you all the best, and I hope when we see you the next time, you have kind of considered the facts that we have told you and incorporated in your research. Thank you.
Okay, thank you. Yes, thank you.
Thank you again.
Yeah,
Thank you so
saying enough.
much, teachers. We would like to move to our next presenter now. I would like to, yes, thank you. Can you mute yourself now? We would like to move to our next presenter, Vadyam Sleeser, and they will be presenting their presentation on additive design of metamaterial based on quasi-fractal approach. Dear presenter, you may please present your paper.
Quasi-fractal approach. The entry of humanity into the Internet of Things era has significantly expanded the range of tasks solved using wireless access technologies. At the same time, taking into account the mobility of users of telecommunication services, preferences given to compact solutions. Regardless of the frequency range used, the main ways to achieve miniaturization are, first of all, the use of electrically small antennas as well as the use of metamaterials. Since the elementary cells of a metamaterial in many cases have multi-component structures, the known set of approaches to the synthesis of such can be extended by passing to the 3D topology of the constituent elements. Thus, the purpose of the report is to study the electromagnetic parameters of 3D SRR structures, in which the constituent elements are modeled on the basis of quasi-fractals. Sufficiently tested and has proven itself on the positive side. The study began by analyzing 2 ribbon split rings without a conductor with end grooves in the outer tape. The grooves were formed using the meander fractal initiator of the first iteration, allowing for the formation of broadband zones of negative magnetic permeability. ANSYS HFSS simulator was used to study the electromagnetic properties of various metamaterial cell design with the 3D topology designer allowing for the implementation of a configuration with 24 grooves evenly spaced around the circumference. The simulation results show many frequency ranges with negative magnetic permeability and B-negative zones with negative dielectric permittivity. The effects of various parameters of the metacell geometry on the zones was analyzed using special macros embedded in HFSS for calculating epsilon and mu values. It should be noted that in the considered version of the outer tape, the depth of the grooves was constant along the triolate. At the same time, the grooves themselves from different ends of the outer tape were arranged in a checkerboard pattern. Next, we study the influence of the variable depth of the grooves, for example, when the cuts of the rings lie in the horizontal plane and the grooves on the end surface of the outer tape are symmetrical. Efforts made to vary the design of the metacell made it possible to achieve the appearance of the DNG band in the range of 640 to 950 MHz. A variant of the horizontal arrangement of rings was also studied, which is a typical case in the formation of metalenses. At variable depth of the grooves, the DNG section shifted to the regions of 7.0 to 7.7 and 7.9 to 9.25 GHz, while a zone of negative magnetic permeability values covers a continuous region starting from about 5.3 GHz and beyond 10 GHz. The latter testifies to the prospects of using such structures for construction magnetic metalenses, for example, for electron microscopes, naturally, provided that the size of metarings are scaled in accordance with the given wavelength. At the end of the first stage of research, a variant of the ring structure with an extremal tape in the form of meander was considered. For this design, the area of negative permeability of interests in considered in the low frequency range up to about 1.4 GHz. At the second stage of the study, a combination of split rings and a stage conductor was used in the construction of metacells. The grooves in the upper strip of the metacell varied in depth according to a sinusoidal law approximating the second iteration of the quasi-fractal based off the meander. This design achieves a low frequency range with a negative permittivity and permeability from 100 to 336 MHz. The distance of the conductor from the surface of the ring did not significantly affect the width of the DNG range in the low frequency region, since an increase in this distance from 4 to 10 mm only shift the upper limit of the range to 345.6 MHz. A more significant result regarding the influence of the length of the low-frequency zone DNG made it possible to obtain an alternative variant of changing the design of the metacell, which consists of the vertical turn of the wire and the location of the cuts of the tapes in the horizontal plane. As can be seen, the transition to the vertical wire extended the upper limit of the DNG zone in the low-frequency region to 647 MHz. At the same time, the second DNG zone was localized in the region of 4.65 to 5.15 GHz. Summarizing the results of the second stage, we can draw intermediate conclusions. In particular, in order for the DNG zone to be in the lower frequency region, it is necessary to place the cut in the outer tape at the top of the z-axis or in the horizontal plane. The location of the cut in the outer ring on the z-axis from below leads to the disappearance of DNG in the low frequency region. To study the impact of deviation angles of conductor orientation, a limiting case of 45-degree deviation was considered. The result was a narrowing of the B-negative zone to 340 MHz, primarily due to ring rotation to align slots with the vertical axis. Thus, to maximize the expansion of the lower DNG strip, cuts in the ribbons must be in a horizontal plane. The deviation of the conductor from the vertical at an angle of up to 45 degrees does not affect significantly. The next stage of the research consisted of the translation to a conductor located perpendicular to the plane of the rings. At the same time, the grooves in the upper cut tape at both ends had a variable depth and were located in a synchronous manner, that is, the grooves from opposite ends were opposite each other. An important nuance was also that the sections of the tapes lay in a horizontal plane. As a result of this modification of the metacell design, there was a significant expansion of the DNG bandwidth and lower frequencies, ranging from 25.02 MHz to about 652 MHz. This corresponds to 185.22%, then converted to a relative frequency value according to the factorial bandwidth formula. There are also DNG bands in the ranges from 3.25 to 3.7 GHz and from 4.1 to 5.05 GHz. Another of these zones is in the range of 8.25 to 8.75 GHz. Thus, the turn of the conductor perpendicular to the plane of the ring stopped design in an effective solution that led to the expansion of the bandwidth in the corresponding DNG bands. As expected, with the vertical arrangement of the conductor and the horizontal arrangement of the ring in the XY plane, the DNG band disappears in the low frequency region. However, in this case, if the conductor is placed horizontally, parallel to the plane of the rings as shown in slide, then the specified low frequency section is restored. At the same time, its width becomes relatively smaller, 1.0 to 0.44 GHz. At the same time, the DNG bandwidth in the region of 7.05 to 7.75 GHz is 700 MHz. If, however, the conductor is placed in the intra-annual space, then regardless of its orientation relative to the cuts in the rings, the low frequency range of the DNG disappears. In the final stage of research, the metacell design with a conductor perpendicular to the plane of the ring and with cuts in the tips located on the vertical axis was considered. When the cuts are on the z-axis with the same widths as a conductor, the low-frequency DNG region disappears, but is preserved in the region of 4.8 to 6.35 GHz. The deviation of the cut in the upper ring from the z-axis in this case leads to the restoration and expansion of the band of the low frequency section of the DNG as the cuts deviate from the vertical position. The maximum strip in this design option is achieved when the cuts are located in a horizontal plane deviation 90 degrees from the z-axis. At the same time, the presence of a low-frequency DNG section at 45 and 90 degree angles of the cut from the z-axis depends on the width of the cut in the ring. Future research should focus on expanding the low-frequency range and obtaining more broadband DNG solution across the spectrum. These could involve using a sequence of grooves in the inner tape and exploring the use of other geometric figures as initiators of quasi-fractals, as well as studying the influence of dielectric fields. Additionally, research will investigate preserving the properties of a single cell in a multi-cell metamaterial, considering both relative position and multi-orientation of the metacells in a space. The best solution for achieving negative dielectric permittivity and magnetic permeability was found to be using a conductor perpendicular to the plane of the rings with synchronous variable deep grooves on both ends of the outer tape. The use of a two-ribbon structure as a basis of a metamaterial cell provides a wider relative frequency band compared to using them as an antenna. The indicator of the relative frequency band of the DNG zone achieved in this case was 185.22%. In previous works, this value does not exceed 132%. This concluding of my briefing. Thank you for your attention.
Yeah, Vidam, nice presentation, but it is little bit my out of research work. But as per my understanding, I have 2-3 queries for the understanding. You have said that design the mathematical things. So what is your contribution as a mathematical design? Am I audible?
Yes, thank you, Mr. Chairman. Thank you for your demonstration, my presentation, and your question. We use a simulator with ANSYS HFSS program. Mathematical this.
Yeah. As per my understanding, you have used the 3D SSR model. So in this,
Yes.
What is your contribution?
We propose the new design metamaterial cell with perpendicular conductor to face of SRR split ring resonators, and additional modulation of phase split ring resonator with quasi-fractal gaps.
And how to fine-tune the localization, the DNG and central DNG zone?
Main task of our research was localization double negative zone in low frequency diapason. We have good result in this area.
Okay, thank you. Yes, over to you, Dr. Meenakshi.
Thank you. So very nice presentation. I just had a small observation, like when the graphs that you've shown where you plot the frequency versus the RE epsilon and RE mu. So I could see that at lower frequencies, there's too much of a deviation, as in it becomes almost zero what you achieve, and then you do achieve a, kind of a constant graph beyond that. So, but in your output or in your conclusion, I couldn't see any analysis of the graphs that you have plotted, or why is the behavior at lower frequencies different than, let's say, when you move somewhere around 4 gigahertz or so. So is there any kind of an explanation which you do have in your project which you have not mentioned here?
We will continue our research in this area. This result was given by discrete on frequency 100 megahertz. I hope we should decrease this interval to 1 megahertz, and for more detailed study. But for this need very big time for calculation and simulation this model.
Yeah, because the frequency will play a major role on how your curves are going to be. So if your frequency is too high, probably you don't get the requisite results. You probably need to bring it down to a lower frequency for your analysis to be proper. That's my understanding. Thank you so very much.
Thank you. Thank you.
Thank you so much, Vedant. We will now like to move on to the next presenter. I'd like to request our next presenter, respective title, Multitask and Multi-Team Work Order Scheduling Using Non-Dominated Sorting Genetic Algorithm. Dear presenter, please begin your presentation.
Hello, can you hear my voice?
Yes,
Yes,
yes.
Yeah. And this is my life. Thank you, Ashley. Good afternoon, ladies and gentlemen, to the chairman and the auditor of the 8th International Congress on Information and Communication Technology. My name is Lê Hồng Trip, and it is my greatest honor to present to the Committee on Research Achievement title Multitask and Multi-Team Work Order Scheduling by using non-dominated sorting genetic algorithm tool. This session is co-organized by 6 authors. Me and Mr. Hai will be the corresponding presenter for the curriculum. The research is conducted in affiliation with the University of Technology and Vietnam National University. In our conference session, we'll cover by 5 sessions of our research paper. The first one is introducing the problem statement and defining objective. Reverse approach to the issue. Our new methodology for job scaling, result of experiment, and the final is filter scope of our research. And now my partner Hai will guide you through our predicament presentation.
Yeah, Hải, can you unmute? Can you unmute your micro?
Okay, there it is. Can you hear my voice now? Okay. Okay. Thank you for the introductions. So in general terms, job scheduling is an important optimization framework in computer science. So scheduling a set of jobs require feasible and logical ordering to ensure resource utilizations. So work order have similar aspects to job scheduling, but with strict timing, concurrency, and multitasking requirements. So it is becoming increasingly essential that first, the workforce is be able to perform as many tasks as possible, and second, a task can be executed by as many available personnel as possible. So with the above knowledge of job scheduling, we come to define the fundamental problems, strategic scheduling. Now, when we talk about strategic, we use raw input information of particular task to perform scheduling. We do not care how hard the task is or what the skills are required to perform it. So the knowledge domain is out of the window. So in real life situations, this is a fundamental directives where tasks are recorded and assigned based on circumstances. For situations, they are performed by oil rig maintenance teams. In cases where distances are far away and resources or workers are limited, time plays a key figure, and we need to promote on-point assignments, coping with multitask and multi-team directives. So our problem is a branch of hybrid task scheduling where multi-objective is the main attribute. Further down the taxonomy tree, we observe the multitask and multi-team is an important addition to the predecessor. What makes this possible is thanks to the genetic factors of NSG2 that we're going to adapt our problem on. So we would like to briefly walk through some of the dataset comments that we use to engage in the experiment. Our dataset has 6 attributes, namely team for a group of workers with their locations, a pair of starting dates and ending date of a task, the estimated time duration for the task, the location ID, and the available resource. We would define several sets that encapsulate these informations, namely the set T for task, E for interval, tau for teams, S for workspace, D for the timeline, T for the work personnel, set R for the available resources, and finally the last set Z for work personnel with known location and team informations. All these sets have specific mappings via functions to identify which information links with which. So we additionally define functions for getting the real versus predicted value for a given task. These values are the scheduled dates in the set D. The function F is for the starting date and the function G is for the ending date. From there, we determine the ground truth set, which is called lambda, which is a pair of real value function F and G, and the theta prediction set, which is a pair of predicted values from function F and function G. And now on this slide, we can now show you the objective functions that we'll be dealing with regards to the multi-objective scaling. So on this slide, we can see that this nested combination of summation tells us that we need to allot the maximum number of working people per day and do not exceed the provided resources. So for each pair of element in each set Z, D, and T, we need to find a sequence of arrangement X that this sequence do not exceed the cardinality of R. So we put hard constraints that must be satisfied for the validity of the arrangements. That the start and completion time must fall in a given time allotment delta, and then as well as a resource constraint. Minimum total execution time is not required, but it's preferable to gain. So has there been any attempts or reasonable scaling apparatuses? Well, there has been, but currently this is a pretty new area in the field of computing. So predecessor approaches can be best categorized into three groups. The first group is brute force, which favors efficiency in case of severe performance blockage. The second one is divide and conquer, which bumps up the performance a little bit, but still trades with lower effectiveness. And the last category is heuristic, which makes good balance between the two. However, it can be done at a much better level with lowest computing cost. Therefore, we believe our approach is the best way to reach really far into the future of scheduling. And now I'll come back to my partner, Mr. Chiết, to show you our evolutionary methodology.
Thank you, Mr. Hải, for the briefing. Now you can see our approach in a different path and allows for vast customization to match any scheduling needs, and it also provides robust clean and swap exchange of task procedures. These new manufacturers are brave payment for new and intended focus for multi-objective scheduling. For our framework, it is based on non-dominated sorting genetic algorithm 2 or NSGA2. First, we select suitable data recitation and gateway objective function for structure. Thereafter, we shall run it through a dominance relation to its subject bar Pareto frontier, which contains SQL in similar grouping. After that, we choose optimal approach by ranking for the next generation by sorting the solution batch and calculate mathematical distance. Then we perform the transfer operation to move them to the next generation pool. Our chosen chromosome representation is represented in this slide. We divide the mass that needs to be redacted into individual blocks along with its task corresponding ID. In the NSGA2 original implementation, we can perform crossover and mutation operation concurrently in order to generate new lists and populate the gene pool. In this research, we have made significant customization to the method of generation suitable for task scaling for a particular strand of task information. We determine points of cutoff X1 and X2 based on the distribution value beta in order to swap genes. If mutation is necessary, we use mutation index parameter called NF to perform polynomial mutation. We see robots by Def and his associated in 1999. To see further detail on how we perform the entire framework, we invite you to consult our papers with corresponding title for the complete procedures. After we resolved technical challenge, we conducted experiment to compare our method with other. We choose testing environment work carefully set up to avoid errors. We define objective parameter, and we also allocated length of 216 for on task and population size of 20. We also use the adjusted NSA2 method with our approach and established checkpoint for monitoring performance metric. So we expect 4 hours. The first one is violation of deadline constraint, result constraint, total task time, and the final is execution timeline. On this slide, we can clearly see the advantages posed by adjusted NSA2 on the first 2 hours. We should not realize the 4-hour main method, and the override is for the traditional checkup. NSA2 for scaling. Our method converts faster than the original NSA2 in figure A, and is faster by using all available resources in figure B. The first hour show around 300 unit hour. Shorter execution time for adjusted NSA2. The last figure also shows high stability and completion of all tasks within around 60 days, or about 2 months, with minimal disproportionate scaling, unlike original NSA2. And let's take a look at how our model assigns tasks by using a Gantt chart for the first 15 jobs over a 31-day period. The adjusted NSA2 approach to minimal overlap and all tasks are well coordinated, creating a seamless connection between them. But in contrast, the binary approach is significant overlap with multiple tasks starting on the same day, resulting in workers having a judgment between tasks and potentially causing delays. So this highlights the shortcoming of traditional method and demonstrate the superiority of our new scaling approach. In conclusion, we have customized NSA2 according to different requirements for scaling, resulting in notable improvement in solving case problems with our dataset. Also, although we only focus on the original NSA2 with added customization, we plan to investigate other variants in the future. And by limitation in computing power, this also prevented us from using high-value parameter. However, this goal do not affect the final product of the experiment. In the future, we like to resolve all obstacles mentioned as well as in supporting information to the dataset and expand the sequence for better predictive arrangement. Finally, we would like to thank to the Vietnam National University or Ho Chi Minh City for funding this project. We send our sincere thanks to individual system, Joint Stock Company for their IBS travel and publication scholarship, as well as our friends and families. Thank you for listening. We happily appreciate the chance to present our work for this symposium, and we are glad to receive questions from respected scholars.
Yeah, thank you, Lee and David. Okay, nice presentation, but I'm little bit wondering about that you are working with the multitask and multi-team work. So what the population size you have used? What the population size you have used?
Sorry, can you repeat the question?
What the population size you have used?
We use around
20. It's 20.
Yes.
Yeah,
Yes, 20.
I think it's very less numbers because you are working with the multitask and multi-team. So I think you need to increase also on that part, and then after that, you have find out the complexity of the genetic algorithm.
I would say that because our data set was primarily limited in the original gathering of the data. So essentially, when we gather the data from the raw scheduling apparatus from the oil rigs, they have several cutoffs periods that we don't record it in the schedule. So therefore, if we try to increase the population size a bit further, this could cause like there will be some missing parts in the timelines that the schedule is able to grasp. So therefore, we try to use a smaller population size first, and then if we have improvements, we can try to upgrade it to a larger population size, as you suggested.
Yeah, but actually you can see here the total number of epochs are the very high and the size is very less. So
Right.
in that case, maybe you need to fine tune as per your data set. You need to increase the data population size, and after that also reduce the number of the epochs.
But,
so
yes,
I hope you need to fine tune in your objective function. So based on this, you can get the good results also, as per my suggestion, I hope.
Yes, thank you for your suggestions. We will try to increase the population size in our future testings.
Yeah. Okay.
Thank you very much.
Thank you. Yes, over to you, Dr. Meenakshi.
So I just had two questions. One is that when you talk about resource allocation, job scheduling, so what all resources were you considering when doing this specific research of yours?
We would like some few minutes to discuss this with our partners.
Yeah, so probably you can. And second was in your outputs which you showed, the graph number 1 and graph number 4, out 1 and out 4. I couldn't kind of understand the inference that you're drawing out of them, because in graph 4, I didn't see your binary average showing anywhere. Like it was just the green line and the orange was missing.
For this particular questions in graph number 4, as you can see, it's quite small to see the changes.
You stopped your presentation. Could you just reshare it?
I just stopped my presentation. I'm sorry. Let me step back the screen. Okay, can you see it now? Can you see?
Yes.
Okay. In this for this particular graph, in graph 4, if I can zoom it in, I don't know if I can zoom this in, but if you can see the adjusted NSJ2, this thing measures the total days for all task completions, which means that we allocate, which means that we evaluate how many days it would take for the algorithms to organize every single task based on given resources, such as the number of workers available at that time, how far is it from, how much time it takes to take from the shore to the oil rigs itself. And there were a lot of resource constraints that we wanted to list, but in this case, we validate every single resources and then we allot them into a single timeline. So we want to see which algorithms assign every single task with an allotment time that is most stable, the most stable allotment time. So in this graph, you can see that the green line is very stable, which is our algorithm. But the binary is very unstable. You can see that for the very first ones, they have a jump from 60 and then go to 65. It's very minor. But if you count days by days, this will be a huge hassle for the oil maintenance workers. So we have to reduce it, minimize it, make it more stable as possible. So I just said NSA2 accomplish this by making it stable at 60 days. So it's consistently stable at 60 days. Yes.
Also, there's a small observation. I don't know why your number of epochs in every graph are different. Like if you've trained the model for 2000 epochs, the results that you're displaying should be the x-axis should be same for all.
Yes. for the reason that we shorten the epochs showing in this graph, because when we look at the entire runs for 2000 epochs, we see that the results after some epochs, for example, in output 4, after 181, it remains stable. It remains stable every single run.
So that means that's where you should have put a stopping condition, as Dr.
Yes,
Ramesh
yeah,
mentioned. Probably you should have. Yeah.
Yeah, I understand your suggestions. We could add some early stoppings to the algorithms so that it will stop epochs that is think is perfect. But if you can see back in this slide, you can see we want to measure this output 2 here. So you can see that if we take it for longer runs, then the number of exceeded workers will go down to the minimum. So essentially, it creates some sort of a antinomian. Like if we run it for longer, the other metrics will remain stable, but this metrics right here will just come to minimum as possible. So we just want to show that the very first few epochs we have significant advantage over the traditional ones.
Thank you so much.
I think the epoch is a number of the epoch go along the ICICT.
Yes, right.
Yeah, and whenever we have more epochs to be invested into the training, right? We can decrease the loss, improve the accuracies, right?
But Dr. Pham, actually, the population size is very less. Then that's why we are wondering actually.
This to be more clarification, the data that the team is using is come from an actual company. You see the National Physical Corporation. This is the multitask, multi-team project data that they use in their own, allocation for scheduling people to go to the sea for the chemical, oil projects. So the team have tried different parameters, and during the time they select different population size, different methodology. It's come out that this may seem to be the optimal set of the hyperparameters. Yeah. So
okay.
Agree. We understand your advice,
yeah,
and we
yes,
try
yes.
again.
I hope in the coming research try to incorporate and especially more focus on the objective function. I hope at that place you need to more concentrate in the coming research or the future research.
Thank you, Professor.
Thank you for your suggestions. Thank you.
Yes,
you.
over to you, Anjali.
Thank you, sir. Thank you so much, Trip. We will now like to move on to our next presenter. I would like to request the next presenter, Stephen Aziz, to please present their paper on the topic Representation Learning for Spatial Reuse in IEEE 802.11ax Compliance Edge Intelligence. Dear presenter, please present your paper.
Hello, everyone. My name is Stephen Aziz, and I'll be presenting our paper topic, Representation Learning for Spatial Reuse in IEEE 802.11ax Compliance Edge Intelligence. So first of all, what is this wireless technology about? As we all know, wireless technology suffers dramatic decrease when in a large crowded scenarios, especially in dense network environments. Take, for example, in a very large stadium, the number of people connected to a specific wireless technology always decreases the network throughput and network performance as a whole. So this work tries to understand how we can further improve this technology. Now, taking into consideration our IEEE 11AX and 11AC. 11AX is the latest technology in terms of wireless technology compared to the preceding one, which is 11AC, which is the preceding one. So these two are trying to improve our wireless network, especially in very dense environment or very dense scenario. So in comparing these two, the first one, which is generally 11AX, tries to operate on a 2.4 gigahertz technology compared to the first one. So with this technology, we are trying to improve the network throughput and also reduce the modulation sub-carriers for this technology and for data transfer and improve data transfer and data rates. Now, for our background, our 11AX is designed to ensure reliable coexistence with both legacy technologies and the new technologies. However, in real-world ultra-dense deployments, these mechanisms cannot fulfill and manage network coexistence, and therefore there's always interference and collision in wireless technology. And given this design of this new and latest wireless network, that means the 11AX and the legacy devices, these two always compete when they are coexist together and when they are collocated together. So fair coexistence in a dense network scenario seems practically impossible, as the access point is very dense, and also this coexistence always cause interference between each other. So now the challenge is, since this new technology use what we call this CCA, the Clear Channel Assessment and Collision Avoidance Protocol. So as this network grows large, there's always something we call a collision and overlapping of channels that collides with other coexisting networks and try to degrade the network performance and the network throughput at large. So now, in this case now, take for example our first access point and our second access point, and take for example in a coexistence with legacy devices. If you have several devices connected to each access point, at the point, one of these devices will be in the same region, in the same zone with the other AP devices. And this can cause collision and interference between these two access points. So now, talking about in a very large environment, in a very large situation, enterprise scenario, in which there are several devices trying to connect, trying to locate, and trying to interact with this access point, there will be several collisions and degradation between this network. So now that brings us to our method, to our objective, which we seek to improve our network throughput and network performance by maximizing transmissions and by classifying interference caused by concurrent transmission, and also evaluate the problem that's carried out specifically for active 11AX coexistence management. Now, this is just our method, which we call affinity GNN, in which we modeled our network topology scenario in two different bits. The first one is the 11AX node and the legacy node. So we use our legacy node as a second hop interaction, which we call the skip orders, and also modeled our direct connection between the 11AX and the 11AX as a direct connection, the first order connection between each other. While with legacy, we model it as a legacy node as a second order interactions between these coexisting devices. So this model is aimed to leverage the notion of skip and direct connections to learn interaction between the wireless networks communication. So using for our framework for architecture now, which we call the affinity GNN, we impute a graph which we modeled this connection. That is the first order connection, which is the direct connection, and the second order direction, which is the skip interaction. So we model this interaction separately, which D representing our direct interaction, and with our X represents our direct interaction. So we model this interaction directly into our model. by classifying these classifying these graphs based on their network interaction and trying to concatenate them in our output direction and try to predict how possible we can effectively detect collision and predict collision in the overall network. So based on this, based on our model, we're able to get some interesting results. Consider our skip interaction, which combines both a direct and indirect connection. We see that we achieve a very high classification accuracy in terms of precision and in terms of general area under the curve accuracy prediction. So we're able to reach about 94% of accuracy prediction and also about 84% for the skip affinity GNN prediction. So we also modeled this our model in terms of missing edges or missing links between these networks, in trying to understand how we can actively capture the network interaction in the case of missing networks or incomplete network as a whole, whether we can accurately capture the whole network completeness or without that. So we modeled this method to classify this based on how the percentages of missing edges or missing links are in this network. As you can see, our skip affinity GNN performs better than a direct affinity GNN. And also in the second one, we can see area under the curve. Although our first prediction, which in terms of skip GNN, achieve higher accuracy at first, but as the missing number of missing edges start to decrease the more and the more, our performance becomes sloppy and try to deep down compared to the direct affinity GNN. So in terms of further results, we try to compare how we further compare our directional results in terms of throughput and in terms of connecting number of devices. As you can see, as when it comes to take for example, two number of devices connecting with our 11AX device, we achieve a high throughput performance. But as this number of legacy devices keeps increasing and keeps increasing, we are getting to see that our performance falls, and we're able to predict the number of throughput based on this performance degradation. And also we're able to compare the feasibility in which we can use our feed-forward neural network and our direct affinity GNN model to compare how we can better predict and see the performance as the number of network increases in that case. So this generally explains how we can capture and how we can predict our coexistence problem, which is one of the most technological advancements of next generation wireless network. So we're able to compare how this wireless network, the latest wireless network, can coexist with legacy network, and also try to predict and assess how the throughput degradation of this wireless network within these wireless networks, and also try to profile a graph-based deep learning approach to intelligently classify how these devices can coexist and predict interference and collision in that case. So that pretty much explains my presentation. Thank you.
Yes, Stephen. You have calculated the throughput, PDF or delay rate or packet loss and other measures of the metrics with the help of we can more understand the communication system. That means that you included in special reviews of the IEEE 802.11.
Yes, we're able to model this based on the packet loss, and also based on the model path, and also based on, take for example, obstacles like war, which can interfere with a performance and which can lower the signal ratio of these networks. We're able to consider what we call signal to noise ratio as well, to help identify possible noise within our signals.
Okay. Yeah, over to you, Dr. Meenakshi.
Yeah, I have just a small observation. I don't know, you in one of the results you show that the throughput was constantly decreasing, and then you do prove that, or you do claim that that the other protocol is having a throughput which is totally increasing. If is there so much of a difference between the two protocols? I somehow do
Yes,
not
yes.
not very convinced with the two results that you've shown, because the throughput cannot be so drastically decreasing in a standardized technology which was existing a couple of years back. So like how have you calculated the results? Was it a simulator? Were you working on NS2, NS3? How did you come, like how were these results generated?
We generate these results based on the data we have, and also based on trying to combine each of these data together. So we are trying to analyze how we can better predict and assess the degradation of this network compared to these other devices. So it is not just that we are trying to make this performance faster. We are just trying to assess how this performance can be predicted and can be assessed or can be evaluated based on this combination of these two scenarios.
No, my question was that were you working with a real-time data where people were actually coming and connecting to a network through different protocols, and then these were the results that you've inferred, or you were using a simulator, a network simulator, and you were trying to run your simulations on that? That I did not find a description anywhere. So that will mean a lot of difference, because when you work in a controlled environment, the way a specific protocol might behave is very, very different from when you put it in a real world scenario. So what was your methodology like? How did you go about generating your results?
Yes, to generate our results, we use this data we have, which is generated, which is already generated for us based on the simulated results of what we have before. So with these simulated results, based on the data of these simulated results, is what we use to assess and use for prediction purpose.
Thank you so much. Thanks.
I hope next presentation also presented by you, no, Stephen?
Yes, yes, yes.
Yes, so we would like to move on to our next presentation. It's by Stephen Aziz only, but it's on the title Representation Learning with Attention for Spatial Reuse Optimization in Dense Blue Areas. Please proceed with your presentations.
Okay, sorry, a minute, please. So this second presentation is more of
Stephen, please come on the what the major contribution you did in this.
Yes, of course.
Methodology, and especially doctors Meenakshi already asked you more focus on which simulator you have used or real time something you have used.
Yes, so this method is just trying to improve the other method in which we are trying to assess and also trying to improve infuse what we call the attention model based on the original improvements of the previous proposed model. So this model is just trying to infuse and understand the effect of transmission power based on this network scenario. So you use this network power to based on weighted edges to assess if this can impact or if this can improve our model to see how we can further classify this possible collision between these networks. So for our method, we use what we call the input as weighted graph. So our normal graph, which include also a weighted number of edges, we are able to assess these edges based on this input by calculating the possible power connection between these two edges, between these two connecting devices, and use it to assess if this can determine or if we can use this to evaluate possible scenarios or possible interference scenarios. So we just use what we call attention mechanism and inbuilt it into our original model, our GNN model, to see how we can better classify this method. And talking about our device, so this skip direct affinity GNN it perform lower in terms of precision and in terms of accuracy than the skip affinity GNN method, which imputes the attention and with this direct affinity attention. Also, in terms of a percentage of missing edges as well. When a number of links is decreasing or they are missing, our skip affinity attention performs better compared to the direct affinity attention. And also, in terms of throughput, when the number of legacy devices are increasing devices, so we're able to compare if this can better improve our method. And as you can see, our skip affinity GNN with attention has a better result than the skip affinity without the attention model. So that is basically what that is about, trying to see if we can improve our method by infusing the attention mechanism to assess the transmission power of these two connecting nodes and to assess if we can further improve this method. So that pretty much explains this presentation.
Yeah. Okay, Stephen. So what the optimization, how to optimize the things actually as per your research?
Yes, we use what we call the Adam optimizer to optimize our model and to get a better classification prediction output.
But for this, any validations you have so that we can understand you optimize the things?
Sorry?
Any validations you have did so that we can understand you optimize the things?
Yes, we run our data based on the test train validation model, and we're able to see that based on this classification, our prediction for each categories improves with this infusion of this attention mechanism.
Okay. Yes, over to you, Dr. Meenakshi.
What classification algorithm have you used, or when you are training it or running the number of epochs? What is the underlying architecture? I couldn't see that anywhere.
The underlying is GNN. Model is GNN. So we are just trying to infuse attention mechanism into our GNN model.
But I could see attention there. Attention predominantly is a part of, it would be a language model. So what was the motivation of using an attention layer in your network when you are just trying to work on a language data?
Yes, the attention is trying to assess how these edges, these connecting devices, the importance or the relative importance, or how a particular edges is much important than the other, or how a device connects faster to a particular device compared to this other. So you're just trying to optimize or assess the weight of these links for each devices by using our attention model to pay more importance to these particular edges compared to these another edges.
But there's a very surprising thing in your results that every time the number of devices are increasing, your throughput is decreasing. We do not expect that out of a network, like its performance should be consistent because we talk about scalability of networks. So I really feel that how are you optimizing, or what is the methodology for optimizing, or what are your objectives and how do you achieve those by way of some performance metrics, plotting epochs versus throughput or number of devices versus throughput does not give a very clear picture about the objectives of the research. Also, I didn't see any, description of results about what were the maximum number of devices that was worked on, how much did the throughput go down, or maybe you can incorporate all this in your next presentation. Thank you so much.
Thank you so much.
Thank you, Stephen. We will now like to move on to our next presenter. I would like to request Nityan Than Kwan to please present their paper on virtual sensor data imputation using generative adversarial imputation, nets and Pearson correlation. Please present your paper.
Hello, can you see my screen and hear me clearly?
Yes, you're audible and your screen is visible as well. Please
okay, thank you. Yeah, hello everyone. My name is Warren from Vietnam. And I am so happy when having a chance to share with you our research It is virtual sensor data imputation using generative adversarial imputation nets and Pearson correlation. My team has 3 members with their names on the screen. In my presentation, there are several points that we're gonna go through. The first one is the motivation of the research. And next, problem definition. And the next one is the methods and the algorithms we were used to solve the problem we defined, the experiments and some results that we did and we achieved in our research, conclusions, and finally the question and answer. Now let's listen to the motivation of our research. I believe that we are living in the era of the 4th industrial revolution, the era of IoT and big data. So sensors are installed and widely used to collect the information from environment. More and more applications and systems are connecting and relying on the data collected by sensors. However, physical sensors are easily impacted by spatial and temporal factors. Therefore, they can be in failing state, and mixing data is unavoidable and pervasive. So we must have a solution to replace physical sensors with virtual sensors in such circumstances. And that is our motivation to do the research. The motivation is that. So what exactly the problem that we have to solve? We have to answer 2 questions. The first one is how to create virtual sensors. In other words, in what ways, in what methods and algorithms that we use to create virtual sensors, and they can be capable of replacing physical sensors. And the second question is, the data generated by virtual sensors are accurate and reliable to be used in reality? That are the 2 questions we have to solve. And in order to answer the 2 questions, we use some methods to achieve our goal. First, we leverage the imputation power of GAN. You can refer to the definition and the model of GAN in the reference. Yes, and thus a GAN is also a GAN generative adversarial nets. So, and we named our approach PGAN virtual sensor, which has 2 components. The first one is generator, and the second one is discriminator, which is highlighted in red on the screen. And they are training in an advisory process to produce the imputed data. And also we inherit the hint component proposed by GAN, and more than that, we calculate the correlation between data collected by sensors. By doing so, we can eliminate the bias and the noise or the less correlative data to establish a new data set, so that we can select the most suitable data to train the virtual sensor creation. And to be more precise, this is the algorithm of our approach. Like I said, the very first step, we try to calculate the Pearson correlation of the data, and then we remove the bias or the less correlative data and create a new data set in the very first step. Then we use this data set to train 2 components. The first one is generator, and the second one is discriminator. And finally, we train with 128 samples per mini batch, and we repeat 10,000 times until the model converge. And in order to evaluate our approach performance, we did some experiments by selecting one physical sensor, which is considered as a faulty sensor to input data. Next, we set 20% of mixing data considered as a missing rate to input data. And finally, we use RMSE and MAE metrics to evaluate the performance of PGAN virtual sensor. And the table number 1, you can see, shows more about the characteristics of the faulty sensor that we have to input. And after doing the experiment, we got some results. And according to the 2 pictures on the screen, you can see the original data and the inputted data by our approach. The distance are not too large, and the trend and distribution of the data set is still preserved. And more than that, you can see the RMSI score consistently scored below 0.1 and 20% better on average for the 3 data sets that we have done the experiment. So with the result I have presented to you, so we can affirm that our approach, PGAN VS or PGAN virtual sensor, is able to work with the missing data problem based on using historical data of the faulty sensor and the data correlation of the neighbor data source nearby. And our approach also provides a potential benefit for businesses when the number of sensors installed in reality can be smaller. So the deployment and management costs can be lower. And when we have a hostile environment, or we have to place a physical sensor in a very extreme environmental condition, we can think about using virtual sensor to replace the physical sensor, because with that condition, it can prevent us from being placed the physical devices. So after doing the research, we can see that we have proposed a new approach to deal with missing data in reality with the data observed by sensors. And the result looks very promising. We also, our approach also opens a benefit for business when we can think about using virtual sensor instead of physical sensors. And for the future solution or for the future development, I think we plan to research more and apply a few methods to increase more virtual sensors can be used in reality. And second, we think about how to define an optimization problem to find the best subset and the optimal sensor placement, so that we can reduce the cost we have to spend and improve the performance and the accuracy and reliability of our approach in the future. Yeah, that's it for my presentation, and I would like to thank you very, very much for spending time hearing my sharing. And here the references, if you would like to refer to the documents or the papers that I based on for my research. Thank you.
Yes, Dr. Meenakshi, over to you.
So very nice presentation. I just had a small, like when you say it was predominantly a data imputation problem. So why would we want to use a generator and a discriminator to, kind of solve that problem when there are classical machine learning algorithms which can do the same job? And also because you do not have sensors, like the amount of sensors is not huge, you do not have a real-time image data coming, where the processing is so difficult that you will need to use a generative adversarial network or some kind of a infrastructure like that. So my concern is, why would we use a complex system like this when we can achieve the same thing using a very, very simple machine learning technique?
Yeah, okay, so thank you for your question, because our intention is use the generator adversarial network because our model use two components to train, right? For the first one, we use the generator to input the data, and we use the discriminator to track or to evaluate, and it based on the real data observed by sensors. So that is the reason we would like to have one. Yes, one input and one based on the real data observed by sensor to track until we have the data looks very, very real. Yeah.
So what is the frequency with which you are capturing the data?
What
is the frequency?
Yeah. Okay, so on the 3 data sets we used, so it depends on the data set for the solar and the traffic. So every 5 minutes we collect one. But for Raspberry Pi, because this data set observe the temperature in a room, so every 10 seconds.
So there is a variation in the frequency with which you are collecting data in all the 3 data sets as well.
Yeah.
Okay, sounds good. Yeah, that's it from my side. Very good presentation. Thank you.
Yeah, thank you.
Yes, over to you, Vanjali.
Thank you so much, Nikhil. We'll now, as we are done with all our presentations, I would like to move to the closing remarks. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on behalf of the whole team, thank you for the support during this version and the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2024 as well. All the presenters would be getting the digital certificates through email within the forwarded to the speaker. So the publication will be live within 6 months. Kindly cooperate. Dr. Meenakshi and Dr. Token of Appreciation is here to the chair sessions on behalf of Team ICICT 2023 and Global Knowledge Research Foundation and partners. We thank you for your presence.
Thank you, Anjali. Thank you.
Thank you so much.
Also, before we end this,
Thank you, Dr.
can
Meenakshi.
we have a quick snapshot, please?
Yeah.
Can we all please turn on our camera? I would like to request everyone to please turn on their cameras so that we can have a snapshot of the conference. Thank you so much. Thank you, everyone. Please stay safe and take care.
Thanks.